We're talking about Chapter 5, Section 7, the Pythagorean Theorem. This is a review from before, so it should start out pretty easy, and then we're going to introduce the new geometry stuff. Your objectives are to use the Pythagorean Theorem and its converse to solve problems, and to use the Pythagorean inequalities to classify triangles. I want you to pause the video and write down your essential questions. Please make sure that you use your DOK chart when you're figuring out what questions you're going to put. Here's your first example. Hopefully you remember the Pythagorean theorem is a squared plus b squared equals c squared. A and b are always going to be the legs of your triangle, and c is always going to be the hypotenuse. So here's a triangle that we're using. You're going to use x minus 2 for a, that quantity squared, plus b is going to be 4, that quantity squared, equals c, which is x. We're trying to find the value of x, so we need to solve for x. We have both variables, so we need to multiply this out and then combine them. X minus 2 squared, that's a binomial squared, so you're going to have to, I don't know what you guys did last year. If you were with me, you did boxes, x minus 2 times x, and then a negative 2, and then you filled in the boxes. Or some of you multiplied both binomials and then you used FOIL. So first, outside, inside, last. Whatever way you did it, you're going to multiply this using that method. I'd like you to pause the video and see if you can finish the problem on your own and then come back and check. So this is going to give me x squared minus 4x plus 4. The 4 squared is going to give me a plus 16 equals, and then the x squared. Then you're going to combine your like terms, and you're going to start trying to isolate the x. So we're going to minus the x squared from both sides. These are going to end up canceling out. These two terms are my like terms, so I end up with a negative 4x plus 20 equals 0. I'm going to add the 4x to both sides. That's gone. I get 20 equals 4x. Divide both sides by 4, and I get x equals 5. Alright, here's your next problem. It says Randy's building a rectangular picture frame. I'm going to draw the picture frame right there. He wants the ratio of the length to the width. So here's your length, here's your width, to be 3 to 1. If your ratio is 3 to 1 and it's length to width, that means your length is the one that's longer. Since the width is the 1, my length is 3 times that. L is going to be 3W. Because it's 3 to 1, the width is 1, and the length is 3 times as big as the width. So 3 times as big as W is your length. It says the diagonal is 12. So that's my diagonal. How wide should the frame be? And they want you to round to the nearest centimeter. Since this is a frame and it's going to be a 90-degree angle in the corner, I have this triangle that I'm working with, where I have my width, my length, we already decided was 3W, and then my hypotenuse is 12. I'm going to use the Pythagorean theorem, so a squared plus b squared equals c squared, where a is going to be your 3W or W, it doesn't matter, plus b is the other leg, equals, we said the hypotenuse was 12. 3W squared plus the W squared is going to be, so this is 9W squared plus 1 more W squared, gives you 10W squared equals 12 squared is 144. Divide both sides by 10. I get W squared equals 144 over 10. You take the square root of both sides. You end up with W being equal to 3.8. Actually, that should be approximately. It's not exactly 3.8, but if you plug it in a calculator, it's about 3.8 centimeters. And that was the question. It says, how wide should the frame be? You should have heard the word Pythagorean triple before, but in case you haven't, these are common Pythagorean triples. So I can have a triangle that is 3, 4, 5. I can have a triangle that is 5, 12, 13, and all of these are 90-degree triangles. So all of these are common Pythagorean triples. It means it works with the Pythagorean theorem and a 90-degree angle, so a right triangle. This question is asking you to find the missing side length, so this length here, and you need to tell if the side length forms a Pythagorean triple. So Pythagorean theorem, like we said before, is a squared plus b squared equals c squared. We're going to substitute 14 for a and 48 for b, so we have 14 squared plus 48 squared equals c squared. 14 squared plus 48 squared gives me 2,500 equals c squared. Find the square root of both sides. I get c equals. Now you have a positive and a negative root. Since we're talking about distance, we're only going to find the positive square root because distance can't be negative. So I have 50 as my positive square root. And because this is a whole number, that means that it is a Pythagorean triple. And that was the second thing that we needed to find. So yes, it is a Pythagorean triple. Next example, we need to find the missing side length and tell if it's a Pythagorean triple again. So Pythagorean theorem, a squared plus b squared equals c squared. We're substituting 4 for a and 12 for c. The reason why 12 is going to get substituted for c and not b this time is because it's opposite the 90-degree angle, which means this is the hypotenuse, and your hypotenuse is always your c value. So we've got 4 squared plus b squared, because we don't know what the other leg is, equals, and we said c was 12. If I square both of these and then subtract, I end up getting b squared equals 128. Again, we only want the positive root because distance isn't negative. So I get b equals the square root of 128 ends up being negative 8 root 2. I simplified this. If you have a question about simplifying roots, make sure that you ask me tomorrow and we can go over where that came from. But that was something that you learned probably in 6th grade, maybe 7th, and definitely 8th. Alright, so here are your two theorems for this section. It's the converse of the Pythagorean theorem, which means the Pythagorean theorem says that if I have a 90-degree triangle, then a squared plus b squared will equal c squared. The converse says if a squared plus b squared equals c squared, then I have a right triangle. And then Pythagorean inequalities theorem is something new for you this year. It says if c is greater than a squared plus b squared, then a triangle ABC is a obtuse triangle. If c is less than a squared plus b squared, then triangle ABC is an acute triangle. So this is a way to check what type of triangle you have. So this says if c is equal to a squared plus b squared, then it's 90, which is the Pythagorean theorem. If c is bigger, then it's obtuse. If c is smaller, then it's acute. 90 means it's equal, obtuse means it's greater, acute means it's less. That's also something you have to memorize. All right, next example. We need to tell if the measures can be the side lengths of a triangle, and then if they are, we need to classify it. So first we're going to determine if the measures can form a triangle. And hopefully you remember from a section before that any two added have to be greater than the third. So 5 plus 7 need to be greater than 10. 5 plus 7 is 12, which is greater than 10. That side works. 7 plus 10 need to be greater than 5. That's 17, which is greater than 5. That one works. Last one, 5 plus 10 need to be bigger than 7. That's 15 is greater than 7, and that one works as well. So yes, this can create a triangle. Now we need to figure out what kind of a triangle. The way we do that is we're going to use the Pythagorean Theorem. So I have a squared plus b squared, and we don't know what this is going to be. If it's equal to c squared, then it's a right. If it's greater, or excuse me, if the c squared is greater, then it's going to be obtuse. If the c squared is less, then it's going to be acute. So first we have to figure out what the relationship is between them. The two smaller values are going to be our legs, and then the larger value is going to be our hypotenuse. So I have 5 squared plus 7 squared, and then I don't know what this relationship is. 10 squared. 10 squared gives me 100. We don't know what the relationship is. 5 squared gives me 25, plus 7 squared is 49. I end up getting 74 here, and I have 100 over there. 100 is greater than 74. Since the hypotenuse is larger than these two values added together, my triangle is obtuse. All right, last one. It says tell if the measure can be the side lengths of a triangle, and then if so, classify. So same thing. Can it be a triangle? And then we need to classify. First we have to figure out if it can be a triangle. I have 5 plus 8, which should be bigger than 17. 5 plus 8 is 13. 13 is not bigger than 17, which means this cannot be a triangle. Cannot be a triangle. Don't forget to write your summary in Edmodo. Make sure you hit all of the topics covered so that you can get full credit. And then if you have any further questions, make sure you write down your questions at the bottom of your notes so that we can talk about it tomorrow.